Trigonometry, the secant, cosecant and cotangent. You need to know about the functions secant, cosecant and cotangent. Sec theta, which is the secant, is 1 over cos theta. Cosec theta, or cosecant, is 1 over sine theta. And cot theta is 1 over tan theta. All three of these are undefined when either cos, sine or tan theta is equal to 0. And there's a few things we have to keep in our minds. Firstly, you should remember the index law, x to the minus 1 is 1 over x. We don't do that in trigonometry. Basically at some point someone made a mistake, and cos to the minus 1 theta is not the same as 1 over cos theta. In my ideal world we would never use cos to the minus 1 and we would just say arc cos, but unfortunately we're not in that world, so we're going to say cos to the minus 1 theta is inverse cos theta, and it doesn't mean 1 over cos theta. We would have to write that as cos theta all to the minus 1. So cos to the minus 1 theta is not the same as sec theta. Sec theta is 1 over cos theta, or cos theta to the minus 1, but cos to the minus 1 theta is the inverse cos of theta, or arc cos theta. And something that will be very useful later on, tan theta is sine theta over cos theta. We should know that from our C2 work. So therefore cot theta is cos theta over sine theta, the reciprocal of it. So some example questions. Will cosec 200 be positive or negative? Well, cosec 200 is the same as 1 over sine 200. If we draw a quick sine graph, we can see that sine 200 is negative, so therefore cosec 2 theta must be negative also. Find the value of sec 280 to 2 decimal places. Because the question says to 2 decimal places, that suggests, well, it doesn't suggest, it means it's not looking for an accurate, exact, third type answer. So we can use our calculator basically. Sec 280 is 1 over cos 280. Just use your calculator. Make sure you're in the right mode, type in the numbers. Sec 280 is 5.76. Cot 115 to 2 decimal places. Well, cot is 1 over tan, so it's 1 over tan 115. Again, it's looking for a decimal answer, so you can use your calculator and get cot of 115 degrees is minus 0.47. Work out the exact value. When you see exact, you are thinking thirds, you are thinking fractions, you are not thinking decimals, and you are not thinking calculators. So sec 210 is 1 over cos 210. If we draw a cos graph, then we see that cos 210 is there, that's 60 below 270, so that's the same as if we go 60 below 90, then that's the same as the value there, just the wrong sign, so it's minus that. So that's cos 30, but that's the wrong sign, so it's a minus cos 30. So it's the same as 1 over minus cos 30. Minus cos 30, or cos 30, is one of the trig ratios you should have learnt. Cos 30 is root 3 over 2, so it's 1 over minus root 3 over 2, which is minus 2 over root 3. That's not terribly satisfying as answers go, because we've got a surd in the denominator, so we can rationalise that by timesing by root 3 over root 3 to get minus 2 root 3 over 3. So sec 210 is minus 2 root 3 over 3. Work out the exact value of cosec 3 pi over 4. We're in radians now, we can tell that because we've got pi's have cropped up. So cosec 3 pi over 4 is the same as 1 over sine 3 pi over 4. If we draw a quick sine graph, 3 pi over 4 is pi over 4 above pi over 2. So if we go pi over 4 below pi over 2, we're at pi over 4. So it's the same as 1 over sine pi over 4. Pi over 4 you may or may not recognise is basically the same as 45 degrees. If it helps to think in terms of degrees, then you remember that that's 1 over root 2. So sine 45 is 1 over root 2, so sine pi over 4 in radians is 1 over root 2. So it's 1 over root 2, or the same as just root 2. So cosec 3 pi over 4 is root 2. You need to make sure when answering these questions in an exam you show enough working out to show the examiner how you got from the question to the answer. Just getting the answer by itself is not really sufficient, because modern fangled calculators could probably help you, but you really do need to show the working out and the steps and the process it goes through. We also need to know the graphs of sec theta, cosec theta and cot theta. So cosec theta is 1 over sine theta. Sine theta goes between -1 and 1. So when it's 0, it's undefined. So at 0, 180 and 360, where sine theta is 0, is undefined. As the graph approaches 0, then you're dividing by a smaller and smaller decimal. So cosec theta gets bigger and bigger and bigger, and at 90, where sine theta is 1, then you've got 1 divided by 1, which is 1. So the basic shape is this blue graph. At 90, sine theta is 1, so cosec theta is 1. At 180, sine theta is 0, so cosec theta is undefined. It's also undefined at 360 and 0 as well, so we have asymptotes at all of those places. And then at 270, sine theta is -1, so it's 1 divided by -1, which is -1. It's an interesting shaped graph. Sec theta is quite similar, really. We can draw the cos graph. This time though, the asymptotes will be at 90 and 270, and the turning points will be at 1, so at 0 and 180. So at 0, cos theta is 1, so sec theta is 1. At 90, cos theta is 0, so sec theta is undefined. So we have asymptote there, and asymptote at 270, and every 180 degrees from that point. Cot theta is 1 over tan theta. Tan is a bit different, remember? And cot theta looks like that, because what's going on here is at that point there, which is 45, that's where tan theta is equal to 1, so cot theta would also be equal to 1 at that point there. At 90, tan theta is tending towards infinity, so 1 divided by infinity is tending towards 0. And at 180, tan theta is 0, so at that point we have the undefined problem again, so we have the asymptote there. So that is the shape of cot theta. So that's the graph. That's sine theta and cosec theta. The key features are the minima and maxima are at 90,1 and 270, -1, and they repeat obviously beyond that every 180 degrees from there forward. And the asymptotes are at 0, 180, 360, and every 180 degrees from there. That's the shape of cosec theta. Sec theta is similar in shape. The minima maxima at 0, 1, 180, -1, 361, and every 180 degrees from there on. And the asymptotes are at 90 and 270, and every 180 degrees from there. That's the graph of sec theta. Cot theta. Asymptotes at 0, 180, 360, and every 180 degrees from that point onwards. So now we can do some sketches of these graphs. Sketch in the interval 0 to 360 the graph of 1 plus sec 2 theta. Sec theta, sec 2 theta, that we know from our C1 work, that's a horizontal stretch scale factor 1/2. And 1 plus sec 2 theta, we know that's a transformation of 1 unit up. So that's what sec theta looks like. So sec theta has asymptotes at 90 and 270. Sec 2 theta is a horizontal stretch of 1/2. So instead of the asymptotes at 45, 135, and so on. So it's a horizontal stretch factor of 1/2, so it squiggles twice as fast. That's sec 2 theta. And 1 plus sec 2 theta moves everything 1 unit up vertically. So that's 1 plus sec 2 theta. So we can use the shapes of graphs and our knowledge of the transformations of graphs to sketch the various graphs.